Two dice are tossed, and x is the absolute difference in the number of dots facing up. So the random variable is absolute differences. First, we can list a table, and it is easier and clearer to see how it goes on. So if I have a two dice, so we can have the dice one's number is 1, 2, 3, 4, 5, 6, and the other dice is 1, 2, 3, 4, 5, 6. So the absolute difference, if I have two dice 1 and 1, the difference will be 0, and 1 and 2, the difference will be 1. And here I can put the 2, 3, 4, 5. And here 2 minus 1 equals 1. 2 minus 2 equals 0. And 2, 3, here's 1, 2, 3, 4. You can make the rest of the table with the following numbers: 0, 1, 2, 3. And for dice 4, 3, 2, 1, 0, 1, 2. And here is the last one is 5, 4, 3, 2, 1, 0. So now in this table it is easier to see the absolute difference. So first, find and plot the PMF of x. We need to find the PMF of x. So the PMF of x, so because x is absolute difference, so the x could be 0, 1, 2, 3, 4, 5, as you see in this table. There's no 6. It's from 0 to 5. So first, PMF x equals 0. You can write down in this form or this, since it's discrete, and or this notation or this notation. They're both the same. And the x equals 0, the probability is 6 over 36. Since it is discrete, so the PMF is just the probability. And you can see the zeros appears 6 times. Here, 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 and here. Now next one is P1. X equals 1. You can count. I have 10 over 36. And P2 is 8 over 36. P3 equals 6 over 36. P4 equals 4 over 36. And P5 is 2 over 36. Next one, we want to find the probability that x is less than 2, less and equal than 2. So we want to find this math representation is the probability of x less than 2. What is x less than 2 mean? This means, because it's discrete, s could be 0 and x could be 1. So we need to consider, oh, and also x equals 2. So from part A, we know the probability of those 3 probabilities. So it's 6 over 36 plus 10 over 36 plus 8 over 36, which is 2/3. Next one, we want to find the expectation and the variance. The expectation, again, every time you write down the expectation, write down the basic definition first and then plug in. That will be easier to calculate. So for the discrete random variable, the expectation is the summation of all possible outcome, I say k. Possible outcome times their weighting. The weighting is pk, which is PMF. You can also write down possible outcomes, I say it's x, then px. And here I consider all possible outcomes, so the outcomes should be 0 to 5. You can write down in this way or in this way, but don't get confused that this is random variable and this x is the outcome. So since I have the summation, we expand the summation. So k equals 0, then the term is 0. K equals 1 is like 1 times p1. P1 from part A we know is 10 over 36. And P2 is 8 over 36. And k equals 3 times P3. P3 is 6 over 36. K equals 4 times P4. P4 is 4 over 36. Plus P5 is 2 over 36. Finally, we get the expectation is 35 divided by 18. Now the variance. The variance is the expectation of x squared minus the expectation squared. We have this now from the expectation. Now we need to calculate the expectation of x squared. So the expectation of x squared, same thing. The expectation is all possible function of outcomes. Now it's a function. So it's a function of outcomes, which is k squared times the PMF. Consider all possible outcomes, so it's from 0 to 5. So you plug in, and finally you will get the answer is 35 divided by 6. So the variance is this answer. You can do it yourself and compare the answer